Okay, in this video I'm going to give an introduction to error coding in EDC15 ECU files. The coding basic structure, this basic structure here, seems to be fairly common through the early EDC files, in other words pre-PD, and then it followed on into the PD files but with a slight change. The change doesn't make it any more complicated apart from muddling up things so that they're a little bit more difficult to find, so they're more complicated in that sense. The basic structure seems to run like this. It seems to run with 4 8-bit potential messages followed by 8 16-bit messages, and each of those is a fault code, so you've got 8 possible fault codes. That seems to be followed by 5 messages for ambient conditions or environmental conditions. In other words, they give you information about the codes when they are represented on a tester in a readout, and then these are followed by debounce counters, and these seem to be arranged in blocks of 3. So there's one debounce counter, and then there's a second debounce counter, and there's a third, and so on. You need a debounce counter for every fault code. So if you've got 0, 1, 2 to 7, so you've got 8, then you will need 8 of these. The designers have saved space in the file though, because what they tend to do is leave out any debounce counter information that would automatically be 0 because there was no fault code in the first place. So to take that to a real life example, what we've got here is 8 codes, 0 to 7, 0, 1, 2 and 3 are not set, so they're 0. 4 and 5 are set, so they've got a value. 6 and 7 are not set, they are 0. And so at the end of this little block there is only this debounce counter section and that one. In other words, we've got this one to go with that fault code, and we've got this one to go with that fault code, and the others have been left off. This does cause some confusion when people look at files, because it means files for each individual bit, and this is for the EGR, may be different sizes, because obviously if there are only 2 codes here, then this file part will be that length because it's only got 2 debounce counter cycles on the end of it. If I were looking at another section of file when it had 3, so 3 codes in it, there will be 3 of these blocks, so there will be another one there with more numbers. And of course if it had 4, then there would be a 4th, and so on. This means that you can't just arrange the file in front of you and look at, let's say, an EGR block, and then underneath look at a speed sensor block, and underneath that a temperature sensor block, because they might be different sizes. So it's not easy to look at them all as one big block of information, because they will start in different points and finish at different points. So that's something to bear in mind. Now, what does some of this information mean? Well, if you look up 19587, you'll find that that's the equivalent of P3131, which is the EGR system regulation range not reached. And this is the exact same one, but the opposite. In other words, it's the range exceeded. So these two just tell us they are the codes for EGR reading as measured by MathFlow not being correct. It's either under reading or over reading. So a particular value is not being reached. The other codes are not present, so we're not looking at those because there aren't any other codes in there on this particular file, but there might be on other files. And then we've got these 5 conditions which help give information about those codes. And these conditions are very difficult to pin down, but I'll give you what I believe they are. I believe that this one here describes engine speed in revs per minute. This one is the current injection quantity in milligrams per stroke. This one is the set point value for EGR regulation. This one is the current value for air mass in milligrams per stroke, and this one is the EGR actuator in 0.01%. In other words, it's telling us that you use 0.01 and it's a percentage when it's displayed. So this information here is used to allow the tester to display the information in a format that makes sense. And this information is used so that the correct description can be picked up to go with whatever description is going to be given for the code. So we've got a code, a description for the code, and some conditions that go with the code for whatever information is being given. That brings us on to a couple of other things that go with this. The obvious thing, obviously, is the debounce, which I've already mentioned. If we pick one, let's just pick that one there. There's a fault code. There are the debounce conditions that go with it. And what this is saying is that the counter has a final value of 65535, which means that if the counter was running and it was a time counter, so that was a time in microseconds, which is what is usually used, it's quite possible that that value would never ever be reached, in which case this fault code would never be set because the count would never actually happen. And here we've got a healing counter, and that's likely to be microseconds again, and it's going to stop at 48. In other words, the healing will be considered healed in 48 microseconds. Well, if that's the case, you might as well call that instant, in which case what we've got is a fault that will instantly heal. They could have set it to 0 and then obviously it would be instant. But if we look at it that way, then what we appear to have here is that fault code will never register because the count will never get completed, and even if it did register, it would instantly heal anyway. So it would appear that that fault never occurs. But what we've got here is what I believe is the event counter. And so what I think happens here, and I could be wrong, and people are welcome to contact me and tell me I've got this bit wrong, but what I believe happens here is that these events are being counted. And so the 17 is the event counter. And so when this has counted 17 occasions or more, then a fault code will be logged. For this one, I think we have exactly the same situation. The fault will never occur time-wise because the time is too great and will never actually reach that time. If it were to occur, it would instantly heal because 48 is such a small number, but we have got a count of 49. So again, I think that what probably happens is, having counted to 49, as soon as we go over 49, this one will be flagged. Now, I could be wrong on this because it's very difficult to pin these things down. Right. Now, prior to that, there are just 4 other little codes. These often look like 2 codes because if you were looking at this whole thing in 16-bit, these 2 here would be one 16-bit code and these 2 bits here would be one 16-bit code. So you need to look at these 2 positions in 8-bit, and then of course you end up with 4. Now, what I believe is that this particular one isn't used, and so the number in it is immaterial. Now, the file that I pulled this from had 195 in it, but I don't think the number in there makes any difference whatsoever. These 2 numbers here are for counting, and they are when the start count for faults should start counting and when the start count for healing should start counting. I'm not 100% sure, but I assume that those are for these 2 here, but they might actually be usable for all of this. I'm not 100% sure. Here we have got what's sometimes called the priority. It's a mixture of priority and readiness. It gives a clue as to how important the ECU memory should consider the fault that's arisen. Generally has the number 0 to 7, 0 being the least important and 3 being the most, but again, some ECUs use slightly different numbers, but these early ones seem to use 0 to 3 as a guide, and so 3 would be the most important. 4, 5, 6 and 7 give more information about the priority of the fault, but don't seem to actually increase the priority of the fault. So it seems that once you get past a certain point, the priority is considered top priority anyway, and that appears to be 3. It looks, as far as I can make out, that if you have a value of 0, the mill light, the little red light, won't come on. If you have a value of 1, it will come on, and if you have a value of 1, it still won't come on. If you have a value of 2, the light will come on, and if you have a value of 3, the light will come on. So that appears to be the way it works, but again, it may be slightly different from file to file because I haven't looked at every single file that I can possibly look at to see. Right, now, as I said, this is roughly how the system works. What I will do in another video is go back to the PD130 and look specifically at the PD130 and how changes might be made, but I thought it'd be important to get a rough idea of what is going on here before we move on to what changes might or might not be made in a file. So I'll stop there.